So in example 5, we're going to leave the world of random numbers behind, and we're going to look at the rough and tumble world of ice cream dispensary. So we have an ice cream machine which gives you servings of ice cream, and the servings vary a little bit. If you're unlucky, the machine will be stingy with you and it will give you just 206 milliliters of ice cream. And if it's a good day for you, if the machine is feeling generous, it'll give you up to 230 milliliters. And essentially it picks a random amount in between 206 and 230, and they're uniformly distributed. And so the question we're trying to answer is, if you go up there with your bowl and you want to predict how much ice cream you'll get. We want to describe what the expected amount of ice cream is in a serving, and also the standard deviation in that quantity. So this is really asking, remember, expected value and mean are the same thing. So we're trying to calculate the expected value or the mean of this uniform distribution and also the standard deviation. And I gave you formulas for those a few slides back, in a slide called Key Properties of the Uniform Distribution. So you can go back and look those up. I'll remind you what they are here. The mean, which is always the same as the expected value, remember by definition those are the same thing, for the uniform distribution is theta 1 plus theta 2 divided by 2, and the theta 1 and theta 2 are the ranges of the interval, the endpoints of the interval. So in this case that's 206 plus 230 divided by 2. Well, that's 436 divided by 2, which is 218. And our units here are milliliters. So the average amount you expect to get when you fill up your bowl at this ice cream machine is 218 milliliters of ice cream. Of course, that's not at all surprising. If you are going to get a random amount between 206 and 230, it's not surprising that in the long run you'll get about halfway between 206 and 230, which is 218. So that's really not surprising at all. The standard deviation I also gave you on that slide several slides ago is theta 2 minus theta 1 divided by 2 square roots of 3. So in this case, theta 2, the big one, is 230. Theta 1 is 206, and we want to divide that by 2 square roots of 3. 230 minus 206 is just 24, because the 200 part cancels. Divided by 2 root 3, that simplifies down to 12 over root 3. And since 12 is 4 times 3, this just gives us 4 times the square root of 3, which I put that into a calculator. It works out to be just a little bit less than 7 milliliters. It's about 6.9 milliliters. So if you fill up your bowl at this ice cream machine, you expect on average to get about 218 milliliters, and the standard deviation on that will be 6.9 milliliters, about 7 milliliters plus or minus from 218. So to recap where these numbers came from, the formulas for the mean and standard deviation, I gave those to you on an early slide in this talk. It was called Key Properties of the Uniform Distribution. And they're fairly straightforward formulas. In particular, the mean is what you would guess. It's just the average of the upper and lower bounds. So 206 plus 230 over 2 gives you an average of 218 milliliters of ice cream per serving. Standard deviation is probably not something you would guess, but if you have the formula handy, it's theta 2 minus theta 1 over 2 root 3. So I just plugged in the theta 2 and theta 1 into those values there, and I simplified it down to 4 root 3, and I got a decimal approximation. That's about 6.9 or about 7 milliliters. So that's your standard deviation in an ice cream serving. And that's the last example, and so that wraps up this lecture on the uniform distribution. The uniform distribution is just the first, it's the easiest of several continuous distributions, so we'll be moving on from here and looking at the famous normal distribution, not the same as the uniform distribution, and also the gamma distribution, which includes the exponential distribution and chi-square distribution. So those are all coming up in the next few lectures here in the probability series on Educator.com. You're watching Will Murray with Educator.com, and thank you very much for joining us. Bye-bye.